Hi, folks. Welcome back to Physics with Captain Rod. So I'm making this video here to provide a quick example of how to handle transformers. So here's a picture. This is just kind of a schematic of what a transformer looks like. Or it's not really what it looks like, but it describes how it works, I guess. And you have an input voltage and an output voltage. And the idea of a transformer is to change voltage up or down. And the changes will occur because of what's called Faraday's law of induction and changing magnetic flux, which is something we have not gotten to in this class, and we're just not going to be able to, and that's okay. For your purposes, just understanding what a transformer is and what it does, and a little experience on how to handle it will be just fine. And what it is it's a device that changes AC voltage up or down. In this picture, here is our input voltage, here's our output voltage. And the changes occur depending on the number of what's called turns, right? Which I usually put N1 and N2, or you'll sometimes hear me call primary. This is the primary side. This is the output side, or sometimes called the secondary side. Now, equation-wise, your output voltage is equal to N2 over N1 times your input voltage. That's an important equation for dealing with transformers. And also, we can talk a little bit about power. Right? If the transformer, if we assume it to be 100% efficient, that means the power on the input side would equal the power on the output side. Now, this doesn't actually happen in reality. There's always going to be a little bit of loss, but it's very common to neglect small things like that. And power can be written current times voltage. So our current in times our power in, our current in times our voltage in, will set equal to our current out times our voltage out. So equation-wise, these are the two things we're going to be dealing with. So in this example, we're trying to change 120 volts to 5 volts. So in my picture, the input is the 120 volts. The output is the 5 volts. And let's see. How many windings should the primary have? That's this if the secondary has 100. So I'm going to take this formula here and just kind of rewrite it. The output voltage is 5 volts. The N2 is 100. The N1 is not known. The input voltage is 120 volts. And now it's just a matter of solving this for N1. So let's see if we multiply both sides by N1. I'm going to go ahead and multiply that right-hand side. And then we just divide by 5. I think that comes out to be 240 windings. Let me look at that just for a moment. No. 100 divided by 5 is 20. Give me a moment here. Yeah, 240 windings. I think that's right. I haven't had my coffee this morning, or much of it. Okay, the next question was about currents. So again, I'm going to rewrite this equation right here. And we want a 10 amp output. And we're looking for the input current. So the current in, we don't know. The voltage in is 120 volts. The current out we were looking for was 10 amps. The voltage out was 5 volts. And I'm going to double check that current. Yep. And it's just a matter now solving for our current in. And I'm just going to write it like this. The volts will cancel. We're going to have 50 over 120. Come out in amps. I'm just going to leave it like that as I don't have a calculator with me. And anyway, this is just meant to be a quick example on how to handle transformers. Any of the ones you have to deal with on your quiz will look virtually the same. I mean, the only thing that can differ really is the unknowns. So I hope that this helps.